All right, warm up. It says the stage at Glen Head Reception Hall is shaped like an isosceles trapezoid. So the first thing we need to do is sketch this trapezoid. So the stage looks something like this. It says that the bases measure 12 feet and 15 feet. So those are going to be our parallel sides. In this case, that would be the top and the bottom. So this one up here would be 12 feet. And this one down here would be the 15-foot section. Then it goes on to tell us that the depth of the stage is 14 feet. Now the depth of the stage is how far you would travel if you started at the back of the stage and you moved all the way to the front. I might have that backwards. Should make a right angle with one of the bases at least. And it tells us that that is 14 feet. They go on to tell us that the stage floor is 3 feet off the ground, but they want me to find the area of this trapezoid. I don't need to know how high off the ground this stage is. That is not the height of the trapezoid. The height of the trapezoid would be from the front of the stage to the back of the stage or vice versa. So we're going to use our formula for the area of a trapezoid. Area of a trapezoid is 1/2 times the height times the sum of the two bases. So you would have 1/2 times that depth of 14 feet times the sum of our two bases, 12 plus 15. And from here you can type that right into your calculator. You find out that the area is 189 feet squared. Does anybody have any questions for me on the warm-up? You'll be turning in the warm-up along with the homework. Go ahead and hang on to these, set them off to the side because we're going to dive right into your notes next. You guys will turn those in at the end of the class period. So we are on page 4 in your notes. Page 4 in the notes. We have to get a little bit of vocabulary out of the way here. First piece of vocabulary is apothegm. The apothegm is a segment in a polygon that goes from the center to the side of the figure and is perpendicular to the side. Thank you, sir. Do you need a writing utensil? Do you need a writing utensil? Okay, go ahead and pull one out, please. So looking at this picture down here, we have a pentagon, a 5-sided figure that is inscribed inside of a circle. In that pentagon, this segment here that goes from P to F, it does not go all the way out to the edge of the circle. It stops there on the side of the pentagon. Here's the side of the pentagon AB, and notice it's making a right angle with that side. That means that that segment FP is the apothegm. Radius. We've talked about a radius before, but we've always been talking about it in terms of a circle. Polygons have radii too. A radius of a polygon is a segment that goes from the center to a vertex of the polygon. And this drawing down here helps to illustrate why we call it a radius. So again, I have this pentagon, this five-sided shape that has been inscribed inside of our circle. And this segment over here that goes from P to A is a vertex of that polygon, but A is also on that circle that is going around the outside of our polygon. So this segment right here is the radius. So if it goes from the center to the side, it's the apothem. Center to the radius, or sorry, center to the vertex, it's a radius.
I need to borrow a student of yours for an interview, Jackson Footman.
Yep, Jackson. I need to borrow you for a second. And then the last thing that we need to make sure to define here is the perimeter. This is the sum of all the side lengths of a polygon. Polygon means any kind of a closed figure with straight sides. But we are going to be focusing on regular polygons. I don't know if you guys remember from when we talked about our quadrilaterals before, but a regular polygon means that all the sides are congruent and all the angles are congruent. We can find the perimeter of a regular polygon by adding up all the sides, or we can take a shortcut. Because it's a regular polygon, all the sides are going to be the same size. So on this pentagon, for example, instead of adding all the sides together when I know they're all exactly the same size, I could take the length of one side and do what to it to find the distance all the way around? If I know all the sides are the same length, rather than adding 10 plus 10 plus 10 plus 10 plus 10, what could I do to shortcut that? 10 times 5. So to find the perimeter of a regular polygon, we take the number of sides that polygon has, we're going to call that n, and we're going to multiply that by the length of one side. We're going to call that s. To find the area of a regular polygon, The area of any regular polygon is 1/2 times the length of the apothem, which we represent with a lowercase a, and then we multiply that by whatever the perimeter is. We represent with that with a capital P. So the perimeter is the number of sides times the length of one of those sides. And the area is 1/2 times the length of the apothem times the perimeter. Now we're going to use the vocabulary and these formulas to answer some questions further down this page. Excuse me. All right. So I have this polygon over here, A, B, C, D, E, F, G, H. It is inscribed inside circle O. That's the center of this circle here. We want to write down segments, angles, or arcs for the following questions, and we're going to find its measurement if it's possible. A radius has to go from where to where on a polygon? Center to a vertex. I see 2 radii that are drawn on this figure up here. What are the 2 radii? OA, yep, and OB goes from the center to a vertex. So we're going to go ahead and write that down here. OA would be a radius, or OB would also be a radius. The apothem goes from where to where? Center to the side. That is this dashed line right here, which terminates right here in point J. Now, I don't know if the letter J showed up on your particular copy of the notes. Several packets, I noticed it just did not print that J. I don't know why. So if your packet does not have the letter J there at that point, please go ahead and add that. So OJ would be an example of an apothem. Minor arc. A minor arc is any arc that is less than 180 degrees, but I want to look specifically at a minor arc that is in between 2 adjacent vertices. So like this one right here, arc BA. I want to look at that one because I want to know how big it is. How many sides does this figure have? 8 sides. It's got this circle around the outside. If I were to start at point B and go all the way around the circle and end at point B again, how many degrees would we have traveled? 360. I want to know how big it is just this little piece. You said there's 8 sides. So these vertices that are touching my circle are dividing that circle up into 8 same-sized arcs. So to find the measure of this minor arc, we're going to do 360 degrees. And we're going to divide that by the number of sides we have. So we're going to divide that by n. What is 360 divided by 8? 45, thank you. A major arc is an arc that is more than 180 degrees. The major arc that I want to look at on this figure goes from B travels this direction around the circle and goes all the way around until we get to point A over here. So I could call that arc BCA, arc BDA, arc BEA. I need to start with where my arc begins. I need to pick one of these other points over here so I know I'm traveling the long way around the circle. And then the last letter has to be A. How would I find the measurement of that major arc? 360 minus this 45 degrees right here. Remember, we just found out that our minor arc is 45 degrees. So we're going to do 360 minus 45. And that gives us 315 degrees. Measure of the central angle. Where is the vertex of a central angle? Right in the middle, right at the center. I only see one angle that was drawn for us already that would be a central angle. What would that angle be? Has its vertex right at the center of the circle. BOA. Angle BOA is the angle made by the two vertices with its center right here. Well, I know that that minor arc between B and A is 45 degrees. So how big is angle BOA? 45 degrees. Right. Last thing that we're going to identify on here is an inscribed angle. Where does the vertex have to be for an inscribed angle? Central angle, vertex is at the center. Where is the vertex for an inscribed angle? Vertex for an inscribed angle is on the circle. The one that I want to look at with you guys is angle OBA, this angle right here. I want to figure out how big that angle is. So if I'm starting at O, and I go to B, and I go over here to A, we said that we know the measurement of this central angle here is 45 degrees. What is the apothem doing to that central angle? It's bisecting it. So how big is this little bit right here from OB just over to the apothem? 22.5. Thank you. And this little half over here would also be 22.5 degrees. So together we get that central angle of 45 degrees. But that's not the angle I'm interested in. I want to find this angle right here. What does the apothem do when it hits the side? What's special about where the apothem hits the side of our polygon? Makes a right angle. I want you to look at this right here. What is this? It's a right triangle. I know how big two of those angles are. I want to find the measurement of this angle right up here. I know this one's 90, and we just said this one was 22.5. So the measurement of angle OBA plus 90 degrees plus 22.5 degrees is equal to 180 degrees. So we combine our two like terms together, the 90 and the 225. What is 90 plus 22.5? 112.5 degrees equals 180. Then we're going to subtract 112.5 from both sides. What is 180 minus 112.5? 180 minus 112.5. 67.5. All right. Let's look down at number 2, parts A and B. Number 2, part A and part B, we are supposed to find the perimeter and the area of these regular polygons. Remember, regular polygon means all my sides are congruent and all my angles are also congruent. To find the perimeter, the formula that we wrote down at the top of the page was that the perimeter is equal to the number of sides times the length of one side. The area is 1/2 times the length of the apothem times the perimeter. So let's find the perimeter of this shape here in part A. How many sides does that figure have? 5 sides on part A. How big is one of those sides? 18. So 5 times 18 to get my perimeter. What is 5 times 18? 90. Thank you. The units on that is going to be feet. It does not get squared because it's not area. This gets linear units. 90 feet for my perimeter. And now we're going to find the area. Area is equal to 1/2 times the apothem. The apothem goes from where to where? Yep, from the center, not to the vertex though, goes to the side. And it makes a right angle where it hits the side. If it goes to a vertex, it's a radius. So this segment right here is my apothem. And how big is that apothem? So 1/2 times 12.4 times the perimeter that we just found, which was 90. What is 1/2 times 12.4 times 90? One half times 12.4 times 90. 558. This is area, so it gets squared units. So 558 feet squared. Let's try that same thing with this second figure over here in part B. Let's find the perimeter first. Perimeter is equal to number of sides times the length of one side. How many sides does the figure in part B have? 6 sides. How big is one of those sides? 30. So I do 6 times 30 to get my perimeter. What is 6 times 30? 180. What would the units on that be? Meters. 180 meters. And then we go to find the area. Area is equal to 1/2 times the length of the apothem times the perimeter. What is the apothem on this shape? 26. Goes from the center to a side, makes a right angle where it hits the side. So we're going to put 26 in the place of that lowercase a. And the perimeter that we just found was 180. What do we get when we multiply? 1/2 times 26 times 180. 2,340. And what kind of units would we put with that? Close. Meters squared. It is area, so it is meters squared. All right. Let's flip this over. We don't have enough time to finish question number 3, but we're going to get started, and then the video will pick up where we leave off on question number 3. We are supposed to find the area and the perimeter of this polygon. Did they give me the same information that they did before? Do I have the length of one side and the apothem here? What did they give me? A radius from the center to a vertex. This is a radius. We are going to be able to use the information of just how long the radius is to figure out the area and the perimeter of this figure. First thing I'm going to do is I'm going to draw in another radii. So I'm going to go to one of the adjacent vertices here. How big would that radius be? Would also be 4. Next thing we're going to do is find the measurement of the central angle. The measurement of the central angle is 360 degrees divided by however many sides we have. How many sides do we have on this figure? 5 sides. So we do 360 degrees divided by 5. What is 360 divided by 5? 72 degrees. So this angle right here is 72 degrees. We're going to need to find the length of the apothem and the length of a side. Apothem goes from the center to the side. So I'm going to go ahead and draw that in the background here. There's my apothem. And while I'm at it, I'm going to take this little triangle right here and I'm going to draw it off to the side so I can see it a little bit better. All right, so there's that figure. We know that the radius is 4. What is that apothem doing to the larger isosceles triangle that I have going on down here? It's cutting it in half. So what would happen then to this angle up at the top? It would also be cut in half. So I can figure out how big that angle is. It's going to be 72 degrees cut in half. What is 72 divided by 2? 36. So I have a 36 degree angle here, and I have a radius of 4. And on the video tomorrow, I will show you how to use that information to find both the side length and the apothegm. And from that information, we can find the perimeter and the area. The homework that you guys picked up on your way in the door is due on Tuesday next week. The material that will be in the video for tomorrow's lesson is not going to be retaught on Monday. In order to be successful with the lesson on Monday, you're going to have to watch that video. Watch the video while the sub is supervising the class, and I will let you know at the end of the video which homework problems you will be able to do with just the information up through that point. And then we'll do any other homework problem examples on Monday in class so you can complete that homework for Tuesday.